Okay, good evening, everyone. Please go to your Moodle, Chapter 7, and download two workflows, and also there's a PDF file. Yes. So after downloading, please click on lexicon-based sentiment. The difference is this time, we are doing text mining and sentiment analysis. So you might get a notice for updating your Knime. Please press yes. And then, as you see, it wants to install Knime text processing. Just use default settings and just yes, next. And after that, it might ask you to restart your Knime. So please do everything. It might take 5 minutes, so I wait for everyone to do that. Again, download everything from, I think you already downloaded the PowerPoint, but download the remaining and click on lexicon-based sentiment. And it might ask you to do some updates in your Knime. So just do everything and restart your Knime after that. Doesn't let you to download them? Yeah. I think just. No, it lets me download it, lexicon-based. Okay, go to open your Knime first, and from file, import Knime workflow. Yeah, file, import Knime workflow, and then find your lexicon base.
I'm getting an error message, error during load due to missing node extension.
Yes, it's error for updating, so you should press yes. If you just press yes next, this is, you get this error.
Yeah.
Just press yes.
I accept.
Yeah, you need to update it because we do a new module, it's a text mine. Yeah, so when you open the lexicon-based workflow, just yes and accept all the settings. And it might ask you to install Knime text processing.
sure. So, how does the bonus point system work? Like, if you, let's say, give us to the bonus point and stuff, so how does it work? Like,
So
is it at the end of the semester?
at the end of semester.
Okay.
Okay, so hopefully all of you be able to install extensions. So we have two experiments for sentiment analysis. Basically, the first experiment, we have some IMDb movie reviews, and we based on the words that they have. So some words have positive sentiment, some words have negative sentiment, and some words are neutral. So we are with some of all the sentiments. So at the end, based on the dictionary that we have, we end up saying if a certain movie reviews has a positive or negative sentiments. Then we look at the accuracy. We want to see how's the accuracy of our method. In the second workflow, which is if you download it from here, sentiment classification, we took more sophisticated methods. So what we do, basically, based on the word that they have, so each word could be a variable, we predict the sentiment. So it's positive or negative sentiment. And then we do the comparison. We want to see which method is better. So in the second one, we use decision tree learner. So then we try to predict if it's a sentiment is a positive or negative. So having said that, for the first one, which is an easier algorithm, so we need to read our data. So read data. So lexicon-based sentiment, reading that. So if you click on it, I intentionally put it deprecated, because if you Google for your project, you might find some that are deprecated. Again, you can drag and drop a newer one, so you can use with a newer version. But anyway, just click on it. As you see, it has an address from IMDb, from Knime website. We are bringing a CSV file. So it has like index, URL to IMDb website, a text, which is the movie reviews, and also sentiment. So this sentiment comes from human work. So somebody read the movie reviews and then said a movie has a positive or negative sentiment. So this sentiment column was done manually. And you guys know what is IMDb website, right? Is there anyone has a question about what does IMDb website? Okay. Any question about this data that we imported? No. So I don't see, so I just see your eyes. Sometimes your eyes looks like question marks to me. So it's the reason I have to see if you really have question or not. So the next one is a filter, just raw filter. So I'm just saying if there's any missing value, so if there is no review, just exclude it. So exclude row by attribute values, and just saying if there is no sentiment, if there is no dependent value. So because my dependent variables are in the sentiment column, so just exclude that column. So I think that's a straightforward. The next one might be a little confusing for you, but that's okay. So let me just open it here. I think it's straightforward for you. There's a index, URL, review text, and sentiment, but it's not Knime friendly. We need to convert to something Knime friendly. So Knime, just right click on row filter, go to the last item. So we need to convert it to more to Knime friendly. So Knime could apply some algorithms on top of it. So we do it with text string to document. A string is human friendly, document is Knime friendly. So if you double click, so first section is title, is arbitrary. You don't have to even select. So you just select one of the rows to be the title of that document. The second part is important. So you need to identify where is your text. So I'm just saying you can find full text in the text column. Then document source is again arbitrary. Then again, there's a more important one, which is you specify category column. So you have seen that we have a sentiment column, which we identify as the positive or negative sentiment. And also we have a date column, but there's two important things, and the rest is kind of optional. First, where is your text document? Second, where is your classification or category column? So you need to identify these two. But like title column is arbitrary, document source arbitrary, date arbitrary. So these are arbitrary. So you don't see this one? Have you updated first? When you open it, have it ask you to update your Knime? If you haven't updated, you cannot see. So when first you open lexicon-based, it ask you, I put a PDF file in your model, on your model, so it would ask you to press yes. And here you should also next, and then you need to restart your Knime. If you don't update and if you didn't restart, you don't see that module.
I have a question. So
yes.
Since the reviews are like really long sentences, is there a way we can make it 1 for positive and 0 for negative?
So 1 for positive, 0 for negative. What do you mean?
And then we call the reviews like 1 and 0 in terms of like 1, 0, 1.
Still, you can do that, but again, you need to convert it to positive, negative things. So you should do something Knime friendly. Yeah, 0, 1 is mostly Python. Yeah. So. It doesn't. Let me see. Okay, so it might take a little. So after this one, after the insertion finish, close your knife, and then this side, bring the lexicon. Okay, so if you open the third one, now we have a document column. So it has summary of all those previous columns, but is Knime friendly right now. For us, it's not that much great. So look at the column filter. In column filter, I just said exclude everything else because it's not useful. And it's just usable for Knime. So if you right click, look at the result, you might see I just have a document, and the rest is just excluded because it's not it's not usable for Knime. Okay, second one is preprocessing Metanode. So you can, whenever you click, it just open a new window. You can just click close. So when you do sentiment analysis, words, punctuations, subwords doesn't bring any positive sentiments, we can just exclude them. So I have 3 nodes: number filter, punctuation eraser, and subword filter. In each of them, I exclude numbers, punctuations, and subwords. So there's nothing, just you identify your document column and just set raise numbers for me. Punctuation, you just identify document column, and stopwords, you just identify, just say identify column, and okay. And for in case converted, I just convert capital words to lower cases. Any questions about these notes? Preprocessing, I think these are very straightforward. Okay, next part. So I said for lexicon-based sentiment analysis, you need to have a dictionary of positive words and negative words. We just join them to our document column. So if you double click on the first one, look at the address MPQA opinion corpus positive list. So it has positive words. And if you look at them, abide, able, above, accept, these are have some positive sentiments. So with dictionary tagger node, so we're just saying we are from attach them to the document column, and the file that we are reading are in the word column, and all of them has a positive sentiment. Same, we have another file reader. So this time I am bringing negative words like abase, abandon. These have negative sentiments. Again, with the dictionary tagger, I'm joining a negative data dictionary to my document column. And similar to previous one, you just need to identify what's your document column. Again, document column is a column that just is like in the compact, is a type of compact column, a Knime-friendly type column that has their movie reviews and also their classification. Is it positive or negative? This time we're also attaching two dictionaries, positive word dictionary and negative word dictionary. Okay, I wait like a couple of minutes here for your friends to catch up, and if you need to add comments, you can put the comments in your workflow, or if you want to write your comments somewhere else, that's okay. So after just a couple of minutes, I just keep explaining. So by the way, my speed is, am I teaching too fast or very slow? So we already have two files. Yes, somebody already had a lot of effort. They assigned English. These are pre-built positive dictionary and pre-built. I see one of your friends is not muted, so let's see who's not muted. I mute this one. Yeah, I found one of your friends was not muted. So could you be able to, okay. Okay, so I come to your desk, but if you are a Mac user, I mean, first of all, the Mac is not the standard PC, so my knowledge is limited, but when I check with your friends, so if you're a Knime user, close your Knime, then open a blank Knime, then in the file, so you need to go install Knime extensions. So, Amina, so just open a blank Knime. Just close everything. So, could you be able to do that? So look at my monitor. So under File, go to Install Knime extension. When you click here, search for Knime text. Oh. Okay. Text processing. Select and just press next, and install. So you need to install, if you're Mac users, it seems it doesn't go in autopilot way. So you need to go to Knime extension and then select Knime text processing and just next, and install it. So after installing the Knime text processing, you need to restart your Knime and then load the lexicon-based workflows, and you now after that you will be able to see those nodes that are not available. So we already have our document column, which has information of the previous column. And also we already have two dictionaries assigned to our document. Now, what can we do? We can count the words that we have, and also counting how many positive and negative words we have for each movie reviews. Then if we sum them up, we can sum up the positive and negative words, and then say if the text document or like a movie review has a positive sentiment or negative sentiment, right? Does it make sense? So what we want to do? So we want to sum up the positive words and negative words in a movie review and look at the summation if it's positive or negative. Having said that, look at the BOWTF. So it just stands for bag of the words term frequency. So we want to look at the frequency of the words. If you click on this Metanode, first note, it creates bag of the words creator. So you just identify which, where is your Knime friendly column. And if you look at the results, so it created for each word in each movie review, it created a row. So look at the row names. I'm not sure if you can see from my monitor, but it seems the first 34 rows are related to just one movie review. 34. Yeah, look. Yeah. These are the words that are located for the first movie review, but we already excluded some numbers, punctuations, stop words. We already excluded them, but so these are the words that we have in the first movie review, which is like www.imdb 2021-0075. Yeah. For the with the TF one, we can find its frequency. So now you have frequency of each word in each movie review. For example, some of them repeated 3 times, some of them 2 times, and some of them have different sentiment. For example, let's say, what is it? Term frequency. BOW bag of the words. So you make bag of the words from your reviews, and then you find frequency of each word. Yes, absolutely. So some of them, like dual link, has a positive sentiment and repeated twice. Let's see if we can find any negative. I don't see any negative for the first review. Let's just, you found? Yeah. Oh yeah, I see drama, like, yeah. So what I think most of the words are positive, and even the frequency should be much more. Okay, so I think so far this makes sense. So for each movie review, let's open here. For each movie review, we first exclude some characters that doesn't make sense or doesn't have any sentiment. Then with bag of the words, we created all the words. We identify all the words in each movie review, and with TF, term frequency, we counted how many times they're repeated. Any questions? So it should be straightforward. I think the next step should be easy for you too. We're just counting how many positive and negative we have. So we group by, just click. So we just use the document, which is actually has all the data that we want. Look at manual aggregation. I'm just saying that sum up TF apps. So TF apps was term frequency, abstract value. So it just based on, for each movie reviews, is sum of the frequency of all the words. So if you look at the result, so it just said for each movie review how many words are created. Sorry, how many words I have for each movie review. So for first one, I have 55, sorry. Second movie review, 96, and remaining. So there is a reason I'm doing right now. Later you see, maybe I can look at the, like instead of counting how many positive, negative, maybe I can look at proportion of positive, proportion of negative. But for having proportion value, you need to know how many words are existed in your document. Any questions? Still, if you think I talk fast, let me know so I can make it slower. Okay? So don't be shy if I talk too fast.
So how about the group by new column named sum?
I'm just saying that you know, when you do grouping, the grouping is based on each movie review. But for also I want to look at the sum of words. So I'm just saying the aggregation function is summation of the other column, which is TF apps. So next one, which is like just text to a string, it just make it something just format changing. So okay, if you forget, so on the aggregate Metanode, double click. First one text to a string. So I had one column which was my words. I'm just saying convert the format to a string. So if you look at the result, there's not that much of change. Okay, but you see a new column. We just say which one positive, which one is string. Yeah. Means there is nothing in the dictionary. Or maybe neutral. Or if it's they are not in dictionary, probably they are neutral. Like HTTP is neutral. Gear fight is neutral. For me, it could be fight or gear could be something negative. Okay, so I already explained that group by. So the upper branch is aggregate. So just double click. So if with the aggregate one, when we convert text to a string, it just if you look see, I'm just saying my term column is term. And okay, let me show it again. And I'm just saying that when you want convert to a string, take out the sentiment of it. So sentiment was in if you look at the bracket, the sentiment was in it. So this is a tag. I'm just saying just convert it to a text document, and I just want the sentiment part. Yeah. I mean, there's no mathematics here. It's just some conversion. Because for me, tags is not important. The actual sentiment is important. So if the bracket is empty, means although for us maybe you can update the dictionary, but it just means there is no sentiment based on the dictionary that we already joined. So now we can do pivoting and some of the positive and negative sentiments. So again, group by based on the document, because the ID or unique rows is based on the document information or document ID. And I'm just saying do pivoting on sentiments and just sum them up. So if you look at the results now, Now I have how many positive, how many negative words I have in each movie review.
So like that's a win when it's 4 and when it's 3. So that's only for one movie, right? So
Yeah, for first movie, you have 34 positive words and 6 negative words.
then you can see like, all right, this wasn't positive.
Yeah, later I show it to you. Okay, so later maybe you can just subtract them and see how if the absolute if the subtraction is positive sentiment, otherwise negative sentiment. Also for missing value, let's say if it's a missing values for the numbers, just leave as 0. So if there is no positive, no negative words, it just means for a movie review, maybe none of the words is either from positive or negative. So just leave it as 0, means just,
Instead of a question mark.
yeah. Or instead of the negative things. So far, I have a clean table. So document is still, again, it's not human friendly, it is Knime friendly. It has the movie reviews and positive, negative sentiment. Also, we already assigned positive, negative dictionary. In front of it, we have a negative, how many negative words we have, how many positive words we have. So the next part, so what do you guess about the next part? What do you think we should do in the next part? I want to say if one review is positive or negative, what should I do? Yeah, just subtract them and you can say if it's positive or negative. Yes, so it should be straightforward. So we do all of them in calculate the score Metanode. So the goal is we already have from the upper branch, just as a review, we have movie reviews and how many positive and negative words we have. From lower branch, we just have summation of all the words. And summation might be more than positive and negative because we have so many neutral words. So probably lower branch, I mean, for sure, lower branch, when you look at the movies, the number that you see in front of each movie review should be more than positive and negative words because of
all the words in the we haven't
I click
Yeah.
result, double click is configured.
So please double click on calculate the score. We want to just calculate if we have positive or negative sentiment. So first I joiner, I just joined the upper and lower branch. So if you look at the result, I have how many positive, how many negative, and how many words. Again, summation of words should be more than positive and negative because for some movie reviews, maybe you have too many neutral. The next measure is very arbitrary. I'm just renaming some columns. So as you see, for example, positive, I want to have positive words, negative words, and all words. So I just do a renaming here. So for example, the third one was some parentheses TF apps. I changed it to all words. Positive, like plus, some, whatever, I changed it to negative, and same for that. Okay, so if you click on math formula node, you see that I make a sentiment score. So what I did, I said, okay, do subtraction of positive from negative and divided by all the words. So these are my column name. So with the dollar sign, you can, or you can just click on from left side and you drop the values here. But as you see here, I'm just appending a new column. I name it as sentiment score, which is it's just positive minus negative divided by all words. If you click on it, so look at the sentiment score. Again, sentiment score is nothing just negative, positive sentiment minus negative words divided by all words. What you see isn't like, it seems all the sentiments are positive, almost all. There's just a, so you can just do as it is. Say, okay, if it's more than 0, positive, less than 0, negative, and we check it later. But what I want to do, I want maybe subjectively, again, it's very subjectively, I would say don't consider 0 as a threshold. If its sentiment is, let's find the mean of all the sentiments. If it's more than the mean, set is positive. It's less than the mean, negative. But again, that's arbitrary and it's my just subjective idea. Maybe you say, no, I want just have as it is.
What if it's like a neutral, either positive or?
That will be changed by default to 0, right? The previous node. We changed the neutral nodes to 0, right?
Yes, you already made them 0. If there is a neutral,
Yeah, because they have like some 0.
so you can just say greater or equal 0 positive, less than 0 negative. So let's say if the mean is 1, and here we have 1.1234, or we have 0, all of them would be negative, because if the mean is 1, these are less than mean and would be considered as negative.
So even if it's neutral, like a 0, where it's neutral, like that.
Yeah, if you change the threshold to 1, all of them would be negative. Negative sentiment, not negative number.
Is the sentiment score by any chance standard deviation?
No, it should be a standard deviation is just like variant. It's like a look at. So what I do this time, I do group by, and my aggregation function would be mean and standard deviation. So this time also create. So I don't do over any column ID. I just want to do over all the values. But for manual aggregation, I'm calculating the mean and standard deviation. So if you right click and see the group table result, you just have to, I want to work with the mean and standard deviation. Actually, later just work with the mean. But anyway, so these values are in the table, but I want to consider this table as a, I want to consider mean as a threshold. I don't want to work with the table. I want to work as a variable. So I need to convert that column to a variable so later I can implement. Again, these are just Knime logic. Maybe like in Python or your human logic, you say, well, what's the point of doing that? So having said that, I just have a new node, table row to variable. So I convert the table that I had in the previous section to 2 variables. So if you click, so you see that now I want to say consider these 2 columns, mean parentheses sentiment score and some deviation sentiment score, and consider them as a variable. Just no worries, you see later. So okay. So now look at the rule engine. I think here it makes more sense. If you double click on rule engine, look at this from variable list. I have 2 variables of mean and standard deviation. How they came, here I found with group by, I found mean and standard deviation. With table row to variable, I convert that to columns into variables, and later in rule engine I'm using. Okay. Again, if for human, you just see mean and standard deviation from group by table and just implement by your hand. But with Knime, we need to use an extra node to convert to variables. So the language is not that much straightforward, but I'm just saying that look at the sentiment column. If it's more than mean of the sentiment, consider as positive, otherwise negative. I know it doesn't look like a very straightforward if command in Python, but the language is really weird here. But again, the goal of these two lines, just saying if it's your sentiment is more than mean, positive, otherwise negative. But I know it's like true, like equal, whatever. So, and I append a new column, I call it sentiment prediction. So it just say mean warning, but just say I didn't do any change. So if you right click, go to classified values. So look, I have several columns, which some of you already saw them. Positive, negative words, positive words, all words, sentiment score, and my interpretation. So keep in mind, let's just look at the mean. So my mean is 0.07, standard deviation 0.09. I didn't use a standard deviation anyway, but so mean is 0.071. So let's right click on rule engine. So 0.15 is more than 0.07, right? So positive. Yeah, so because I said greater. Yeah. Okay. 36 you said.
Yeah.
0.071. So let's look at it. It looks interesting. So let me. Where was that? I think it was here. And here I said, oh no, I said greater or equal.
So then that should be positive.
Yeah.
Maybe it's rounded up. Maybe it's a little more than 0.071, I guess. Maybe just a rounding error. So with the next column, category to class, I just extract the actual category that was rated by humans. So if you look at the results, I have sentiment prediction and what was graded by human. So the last column on the right is the actual sentiment. Sentiment prediction is how we predicted. So we said if more than mean, positive, otherwise negative. The next node is very arbitrary. I'm just painting them. So if you double click, I just say if in prediction sentiment, if it's negative, red, otherwise positive. If you want to change it, you can double click and then maybe select the blue here. I mean, you don't have to do all the modules that I did here. Some of them are just so for your view. So table. So I think I made both of them very close to each other. So let me change the color. So yeah, negative, maybe brown. Yeah. Execute. It just for doesn't have that much of sentiment meaning here. Yes.
The page that we do it right now. So like when we set like positive, negative, so like that's only for the
Yeah, you can change it. I mean, you don't.
Because document class has some other, like what people like called it positive review, then the prediction called it a negative review. So like maybe we could just paint this other one as well to like see like where it's
Is a Knime limitation. You cannot have two. You just should do one of them. But I got your point. So you change, let's say, then you look at the differences of the colors. Yeah, it's very intuitive, but we cannot do it.
Yeah, because like I can see like here, but then I have to go and check like every one, like what the document class A was positive.
Yeah, I got you. Actually, it's a very good question, but we cannot do it in Knime. So with the scorer node, we can look at the basically accuracy of our prediction. So if you double click, I'm just saying the actual prediction column versus the actual column. So sentiment prediction versus document class. So document class was human, was evaluated by human, and we assume the actual sentiment class. Prediction is based on the rule that we identify. So let's press OK, right click and execute. I do right click and go to accuracy statistics. It's 74% accuracy. So let's change the rule. So you might remember I said if it's more than mean, positive, otherwise negative. So I go back to calculate the score and change it instead of mean, let's change it to 0. So if it's more than 0, positive, otherwise negative, then I have to come to a scorer here and execute. So let's look at the prediction accuracy. So it dropped to 65. So my subjective threshold was better, but maybe you play with the threshold and you end up having a better board. So in this method, as a summary, we assign some positive and negative dictionaries with some of the words, and summation of subtraction of positive and negative, end of like a sentiment score, and based on a rule that we define, we consider a certain text document as a positive or negative. What could be the pros and cons of this method, lexicon-based sentiment prediction? Can you find some problems in this or some advantage of this method? I tell the advantage first. It's very easy. There is no machine learning in it. You just assign somebody already the dictionary, so you just assign and you do basically some summation, subtraction, and you end up saying that if a text has a positive or negative sentiment. So actually, method-wise is very straightforward, and it just needs a high school mathematics to understand it. So what was cons? Yeah, it's just for visualization. That's not he said a good point, but that column is extra. Even you can delete. You don't have to have that note. So if you look at the calculator score, so look at the rule engine. So I cannot find actually good threshold. I just guess maybe mean is a good, but maybe you would say 0. I don't have any reason why mean is better than 0. I should just do all the calculations. So the point is, it's not a sophisticated method, so it could be one of the cons. and you're not sure which threshold is better.
Also, if you were trying to change the language, if you were trying to change like from English to another language, then that would also be difficult to because you have to, like, it would be difficult to like do the nodes and the configuration.
Yes, the right thing. So let's say you want to Chinese, Indian, or like Arabic language. So either you need to have you need to hire so many people to do.
The whole thing again.
Yeah, just this part they should just assign positive, negative sentiment to each word. And sometimes some words could be positive in some sentences, could be negative in other sentences. Let me find a very polite word. Bad user interface. So I know very impolite words that could be positive, but I'm just thinking which. So such a crazy cookie, I love it. So crazy, it seems to be negative, but crazy cookie, love it. It seems you're shocked. Yeah, I mean even crazy could be positive there. It seems you didn't expect that. So I think in every language you can find some words that could be positive, could be negative in other sentences. So having a very large dictionary that you already have positive and negative sentiments may not work every time, because in some sentences could have some positive, some negative words could have positive sentiment in some other sentences. So that's another cons that you might have. Oh, we have almost most. Sure. Yeah, sure, you can do. Thanks for letting me know. Okay, so second part is actually very similar. Since we don't have that much of time, I don't go to the like file reading, pre-processing, and all of them almost the same. But let me just see how can I summarize it. You're welcome. Take care. So first three parts is the same. You just basically read the text document, you make a document column, and that document, and also you do pre-processing, you get rid of improper pre-processing. You get rid of subwords, and basically also get rid of punctuations. If some words NCARS filter, basically, if some words didn't happen frequently, you just exclude them. For example, 3 times you don't you just exclude them. You do a stemming. Basically, you get to a stem of each word. For example, running, run, ran. All of them has one stem. You create the bag of the words and you convert them to the string. I think these things should be pretty similar, and you may later look at them. The differences here, which is so please read the first 3 meta nodes and notes. If you have questions, maybe I can explain later. But the most important part this time, we use words as a variable. So let's say fly or process, these could be a variable. If they happen in one sentence or one tweet or movie review, that column would be 1, otherwise 0. So I do it with the document vector. If you double click, So I have a preprocessed document. So I had a document which has the information of all the information. It was Knime friendly. Now in the previous sections, I did preprocessing. So just right click, look at the document output table. Look. For example, let's look at, click on heart and sort descending. Because right now all of the values are 0. So on heart, right click and sort in the descending format. Okay. So look, heart, it just happened in one of sentence row 1997. It just happened in that column, in that movie review. So it's 1. So, and it didn't happen in the rest. Okay, I think time is a better one. So time happened in the first 5 movie reviews. So the value is 1. If it doesn't happen, it's 0. And same for the other. So just take your table to the left side. So anyway, so you got the point. So we use the word as a variable. So now we can train a model. So we can consider use an algorithm, read these columns as variable and try to predict a dependent variable. And this time, look at the document column. You don't see anything there because here, where did I do that? Not here. In the string to document, as I said, there is 2 important sections, which is you should identify your text and also sentiment. But for title, I just said leave it as empty because it's optional. You don't have to put anything there. Again, let's go back here to the important part. So with the document vector, we make so many new columns. Each column refers to a word. If a word happens in the one review, they are 1, otherwise 0. With category to class, we just extract the class value. So it's positive or negative, which happened, that was done by human, and we add them as a new column. So if you double click, you just see I identify my document column. If you right click and look at the document output table. So now I have one extra column, document class, so positive or negative. So I extract out the class of my movie reviews, which I already put inside the document. The next one is color manager. Again, is for view. You don't have to have this one in your project. So I just said negative red, positive green. Any questions so far? So you got the point. So first of all, we did something similar with the previous one, but we don't assign positive negative dictionary because now we want to do prediction. So we did some pre-processing. Then with document to vector, for each word in my movie reviews, I made a new column with category to class. I just make a new column which has the classification of each movie review. Now I need to divide my data into sections, train and test. But keep in mind, your project, I think at least 2 groups are doing text mining. So you need to do 5-fold cross-validation, which I already explained in previous 9. So with partitioning, I divide my data to section train and test. Look at decision tree learner. If you click on it, I'm just saying where is the location of my document. I mean, my classification, which is on document class, and just leave the remaining as default. And in the decision tree predictor, still you should just leave everything as default. So what it does here, it just look at all of those 0 ones as independent variables, try to predict the document class. Under document class, let me just show it again. It takes a little bit. Okay, so it uses this 0, 1 to predict if it's positive or negative. So predict that last column, which is document class. Any questions so far? I mean, no worries if you have questions. This time I try to explain a little faster because it's very similar to previous one. So I have 2 class classification. And this time I can also have the probability of positive class and negative class. In the previous one, you just have summation of positive words and negative words, and you subtract them and end up saying that if a review is positive or negative. But here, since we did a predictive model, it gives you the probability of being in positive class and probability of being in negative class. So if you right-click, go to classified data. So what you see here, so you see 3 new columns. First one, P of document class equal positive, probability of being positive class. P parentheses document class equal negative, probability of negative. So for the first movie review, probability of being positive is 0.9, probability of being negative is 0.1. So probability of being positive is much more than negative, so it's positive class. What about the second one? Probability of belonging to positive is 0.004, probability of belonging to negative 0.996. So there's a lot more chance of being negative. So it's identified as a negative class. Any questions? So as you see, I have also probability. Since one of the outcomes is probability, I also can have ROC and find area under the curve. I have 2 performance measure node. One of them calculates ROC, another one for just accuracy. Let's right-click on ROC curve and look at the area under the curve. 0.931 is really good. So usually, do you remember we have sensitivity, specificity, and accuracy? So can anyone tell me what is the differences of sensitivity and specificity? What is it for? So what is the differences of sensitivity and specificity? What they are talking about? So basically, so in 2 class classification, you have a upper class or lower class or negative positive class. Sensitivity unless they did, if they didn't do any weird changes, shows you how you are accurate in predicting positive class. Specificity showing how you are accurate in predicting the negative class. But also look at the formula later, because the formula is a little different. So sometimes you have a high sensitivity and very low specificity. It just means your model is not good for predicting negative class. It's just good for positive class, and vice versa. But ROC and area under the curve accounts for both. If you have a very high AUC or area under the curve, it just means your model is probably very good in both classes. So instead of showing sensitivity and specificity, our AUC or area under the curve accounts for both. Very high AUC, it just means your model probably is good for both classes. I think sometimes if they hire you, they ask you what does area under the curve refers to. So you should be ready for such a questions in interviews. Sometimes they ask. So let's look at the accuracy. So 0.918. Do you see a huge improvement? So previously it was like 60, 70%. Now it's 91. So for sure we are way more than 0.5, which is the baseline threshold. Also, you see when you do predictive sentiment classification with the predictive model, the result is much better than lexicon-based prediction. First of all, some words might be positive and negative in different sentences. Also, the threshold is very arbitrary and subjectively. But here, you have a more objective way of classifying, and even your accuracy is much more than the previous section. Any questions? Was it? Do you think it was complicated or it was straightforward? Huh? Which part was more complicated? Okay, I see. Okay, no worries. Please spend a little bit time to review these two workflows. If you end up having questions, reach me office hours or ask me in the next class. Because this class, actually, I wanted to teach the first part, the easier one, much faster. But I'm glad you have good questions. So I think still in the next class, maybe I review a little bit, so it would make more sense for you. And it depends. If your project is related to sentiment analysis, maybe you need to learn them very well. Otherwise, it may or may not be relevant to your project. So, but still, since I got a feedback from you guys, maybe next class I explain a little more. Maybe I explain the sentiment classification workflow more. But okay, thanks for your feedbacks. Since we have a break on Monday, I want you guys to enjoy your break. So there is no more homework for this class. So happy break, fall break. So I hope you enjoy. I think there's a lot of fun these days around Massachusetts. Halloween should be around, so maybe you can enjoy some parties here and there. Okay, thank you. So since at least one of you gave me a feedback about the work complexity of workflow, let's talk about the second one, sentiment classification again. I think second one also covered most of the first part. And again, if you have questions, don't leave your question and don't make everything something ambiguous. Just let me know. And anytime something looks very difficult for you, I can explain next time too. Or maybe I can upload some videos and explain them further. Okay, that's for today. Thank you very much and enjoy your break.